So dear students, in this video we are going to discuss about the gradient of scalar function. Okay, gradient of scalar function. Gradient of scalar function. So what is meant by the gradient of scalar function? Okay. So earlier we have discussed about the function, and also we have discussed about the scalar function. Then also we have discussed about the gradient. Okay. So now we are going to combine the gradient and the scalar function. So as we said, the gradient of scalar function earlier we have said that the gradient of scalar function is the resultant is a vector. So even though this is a scalar, the gradient of scalar, so you take it as say del phi. So this is what? Vector. Okay. So why it comes as a vector? For that, you take this as a, we know already this del phi, you represent it is a grade phi. It is a grade phi. So we know phi is nothing but, so which is a phi is a function which is phi of x, y, z, right? So now we know already what is meant by the grade. We know already what is meant by the grade phi. So this grade phi is nothing but it is the resultant is a vector which is a what? Gradient of the scalar function. So what is this? Actually this is the del. So del is an operator which is operating on the function. So that del phi is represented as grade phi. Okay. So then you know what is meant by the del also. So you know the del is nothing but it is the which is the I dou by dou x plus j dou by dou y plus k dou by dou z. Right. So you write say del is equal to I dou by dou x plus j I cap dou by dou x plus j cap dou by dou y plus k cap dou by dou z. Okay, so this is what del. So if it is del phi, so you can rewrite. So del is acting on the phi, right? So which is acting on the phi. So this phi is, we know that it is phi of x, y, z. Then how can you write this one del phi? This is nothing but I cap dou phi by dou x plus j cap dou phi divided by dou y plus k cap dou phi divided by dou z. Okay, so this is what actually the del phi, right? So as we said, this is what? This is a vector. Why it is a vector? You can see. So phi is a scalar and the del is the vector. So vector is operating on the scalar. So result is a vector. Okay, so you can see the result actually. So this is what the grade phi, right? Grade phi is represented as the del phi. So this del phi is nothing but I cap of dou phi dou x. Nothing but there is a vector, right? So I cap, j cap, k cap. So likely it is there. So you can say that this is the vector. Okay, and you may be knowing earlier, even in your earlier classes from PUC also. So electric field is nothing but negative gradient of the potential. Electric field is represented as the negative gradient of the potential. Nothing but the gradient of potential. Okay, this gradient of potential. So here potential is there. So electric potential, and the gradient of potential is representing in the form of a what? Electric field. So basically the electric field is represented as negative gradient of what? Negative gradient of potential. Okay, so now what are the properties are there for this gradient of scalar function? For that you can take, there are some properties like say gradient of f plus or minus g. So you can take, there are two vectors. F is a vector, f is a one function, j is another function. So then what you take, this gradient of f plus or minus g, you can represent it as grade of f plus or minus grade of G. Okay. Then similarly, you can take another property which is a gradient of C into F. Suppose if it is C into F, C is a constant, then C times of grade F. Okay. So like that you can have many number of properties. From that you can able to find the different properties of the gradient and its gradient of the scalar function. And also there are some other kind of properties also you can take. Actually we have taken here F plus or minus G, and here you can take say gradient of F into G. So if you take F into G, what is happening? So you can take it is say F times of grade G, okay, F times of grade G, F of grade G plus G of grade F. So what I am trying to tell you, so this is another property. So here is F plus G or it may be F minus G, nothing but it is F plus or minus G. So for that you have like this. Then gradient of CF, where C is constant. Then this is gradient of F, gradient of what? Fg. So where F of grade G plus G of grade F. Okay. So like that you can have. Then again you can have a yes, you can have, say for example, gradient of some vector is 0. Say gradient of some vector, you can say which is 0. So you can take this is say grade of say grade phi is 0, for example. Suppose if grade phi is 0, that means you can say this is the null vector. So what is this? It is the null vector. So what is this phi? It is because this is constant. So it is not changing in the magnitude. So the result is basically 0. So okay. So as we say, the grade phi is basically what? Vector, right? From this you know that this grade phi is what? Vector. So even that the result is becoming 0. That's why we call, even though that is 0, but it is what kind of vector? Null vector. So why it is null vector? Because this grade phi is 0. Nothing but this phi is basically a constant. Okay. So like this you have a number of properties. Okay. So you can plan for the number of properties, and then accordingly you can able to find a number of problems also while taking this gradient of scalar function. Okay, so even you can have similarly you can apply for a divergence and also for the curl. Anyway, we will see one by one about this divergence and curl also in the coming class.